And now with a new lesson about lines of symmetry. It says here that a shape has a line of symmetry if, when that shape is folded over the line, the two halves of the shape match up exactly. And this is exactly what we tried today in class when we had that rectangular piece of paper. We found that when we made the rectangular piece of paper a square, we found that it had a line of symmetry this way here. Which means that if I folded the shape into two, if I folded the shape over this line of symmetry, the two halves will match up exactly. And we also found that if we just have another line of symmetry, or if we folded the paper over this line of symmetry over here, the two sides will match up also exactly. And we found also that's when it was a square, not a rectangle. We found also when it was diagonal, whether this way or the other side here, both of them, it means that the square, if I fold it over any of the diagonal lines of symmetry that we have over here, both sides or the two halves of the square will match up exactly. And we came up with the conclusion that any square in the world has 4 lines of symmetry. Okay? So this is just a piece of information that we need to know, and we need also to understand how we can draw the lines of symmetry on a square. Okay, if I just rotate the shape this way, it doesn't mean anything, it's just still a square because it has here 4 right angles. This is the most important thing about a square. You need to study this, guys. The most important thing about a square is that it has 4 equal sides, like all of you know, and 4 right angles. If I move to the next slide over here, we're going to find here us dealing with rectangles. In a rectangle, we agree that it has, yes, we can just draw a line of symmetry over here, because if I fold the shape over this line of symmetry, they're going to match up exactly. And here, if I folded the shape over this line of symmetry, they're going also to match up exactly. But if I folded the shape over this line of symmetry, they will never match up exactly. Yes, it seems like they will match up. If you just look at it, you're going to find, oh, mister, it is actually possible. Just by looking at it, it seems like you will be able to fold it and the 2 parts will match up exactly. But we tried this in class today and we found that it is impossible to fold a rectangular shape over this line of symmetry and the 2 halves match up exactly. It is impossible. So we came up with the conclusion that a rectangular shape has only 2 lines of symmetry. And this was the conclusion. A rectangle has only 2 lines of symmetry. Alright, good. Now we're done with squares and rectangles. What about triangle? Alright, triangle, as all of us know, it has 3 sides, but we have 3 types of triangles. What are they? We have an equilateral triangle. You need to know this, guys. Equilateral triangles. Equilateral triangles means that all the 3 sides of a triangle are equal. Again, please, you need to study this. An equilateral triangle, all the 3 sides are equal, and in this case, you can draw 3 lines of symmetry. 3 lines of symmetry. Alright, so they get changed over here. Okay, so how can we draw them? You can draw the 3 lines of symmetry because you will be asked to draw the lines of symmetry on a shape. If it's rectangle, for example, we agreed here in the middle vertical and here also horizontal, and there is no other way. Okay. Under the rectangle, you just take it from the 3 angles that you have, the 3 vertices. I have here a vertex, so this is an angle. You just start from it and you start to just you start drawing the line and you put it here this way. Another line of symmetry this way from this angle, and it goes straight away this way. You try to make it, of course, in the half exactly. And here another line that comes from up there and it goes down also straight. So an equilateral triangle has 3 lines of symmetry. But what about this? It has 2 equal sides. Guys, you see this line here? And this has the same. It just means that this side is equal to this side. Both of them, it has only 2 sides that are equal. That's why we call it an isosceles triangle. It's only 1 line of symmetry. An isosceles triangle, you just draw it over there from the top and it goes down. An isosceles triangle has only 1 line of symmetry. But what about a shape that doesn't have any equal sides? The 3 sides are just different, they're not equal. We call it a scalene triangle. And a scalene triangle has 0 lines of symmetry. 0 lines of symmetry. Okay, so this is one thing that you need to study all this information, and you start also writing them and you keep studying them before practicing. All right, let's go to the other part of the lesson, which is a shape that has 4 sides. Here, 4 sides, 4 sides, 4 sides. What do we call all of them? We call them quadrilaterals. So all of them are just quadrilaterals. This shape, we call it a parallelogram. This is a parallelogram, and you need to know the difference between a parallelogram and the other shape here, which is a rhombus. Okay, a parallelogram here, it says, this is for your information, you need to study this. The difference between a parallelogram and the rhombus is that a rhombus has 4 equal sides, while a parallelogram has only 2 pairs of equal sides. So here, all the sides are equal. Here, only the opposite sides are equal. This is why this is a parallelogram and this is a rhombus. All right, great. Now we know the difference between a parallelogram and a rhombus. What about the square? Mr. Ahmed, a square also has 4 equal sides, exactly like the rhombus. How can I know the difference? Well, the only difference is that in a square, the 4 angles are right angles, but in a rhombus, 0 right angles. And this is here the second line. The rhombus and the square have 4 equal sides, but the rhombus has 0 right angles. And the last shape that we have over here is a kite. Okay, let's now talk about the lines of symmetry with these 4 quadrilaterals. If we talk about the parallelogram, you just need to know it that it has 0 lines of symmetry. So a parallelogram, which has here 2 opposite equal sides, not all the 4 sides are equal, it has 0 lines of symmetry. But about the rhombus over here, the rhombus has 2 lines of symmetry. Let's draw them together. The 2 lines of symmetry, we go this way exactly because you are asked also to draw the lines of symmetry, to learn how to draw the lines of symmetry of rhombus or any other shapes. Yes, this way. These are 2 lines of symmetry with the rhombus. About the square here, as we agreed earlier, the square has 4 lines of symmetry, and this is how we draw them. And about the kite, as we agreed in class, it has only 1 line of symmetry, and it goes this way, which means that if I fold this shape over this line of symmetry, the 2 halves of the shape will match up exactly. All right. And this is about the quadrilaterals. So this is everything about the quadrilaterals. Of course, you might find some shapes that are not discussed here in this video, and then you will have also to think about them and try to find out, and this will be practiced more later. All right, the next slide here is about circles and an oval shape. As we agreed in class, a circle has just endless lines of symmetry. So you cannot just count them. It's only 1, 2, 3. It's infinite. So it is endless line of symmetry, endless number of lines of symmetry. But while an oval shape has only 2 lines of symmetry, where are they? Here they are. Only 2 lines of symmetry, and this is how we draw them. You need to study all of this. All right, so here we have a line of symmetry that comes this way. If you fold the shape over this line of symmetry here, they will both match up exactly. The 2 halves will just match up exactly. And if I have this line of symmetry here, if I folded the shape over this line of symmetry, the 2 halves also will match up exactly. All right. Now it's about shading. They're giving you here a question asking you to shade 5 more squares to have 2 symmetrical lines. So here we have 2 symmetrical lines. So they need you just to use 5 more squares, or shade 5 more squares to make them look exactly the same. But there is just here a question. There is a mistake. We need to take that square down. That's it. All right. So this is the question here. They're giving you this, and they're asking you to shade 5 more squares to have 2 symmetrical lines. All right, no problem. If I were you, I would just take the first square and shade this part here. And the second, I put it here. And then the third, I just take it and put it there. The fourth, I put it here. And the fifth, you put it here. Now the 2 lines of symmetry, the 2 lines that we have here are symmetrical lines. If I fold this half over this line of symmetry, they're just going to match up exactly with the other half. The same thing exactly if I fold this half here over this line of symmetry, they will going to match up exactly with the other half. All right, the next part over here is if I'm given a shape like this. This shape actually is just a composite shape that consists of how many sides? 6 sides, which makes it a hexagon. So this is a hexagon. And they ask you to find or to draw the lines of symmetry. These are the only 2 lines of symmetry that you can find. Because if you try anything else, like for example, if someone just thinks, oh, I'm gonna draw a line of symmetry over here, no way. If you try to fold this there, you're going to find this vertex here, going to go over there. They're not going to match up exactly. So the last line of symmetry is wrong. It has only 2 lines of symmetry. This is how